Hey everyone, we're about to dive into something that's happening literally right under our feet, but it's almost totally invisible. The soil is breathing. In this explainer, we're going to cover why that matters so much for anything you want to grow and how you can actually help keep your soil alive and breathing easy. Just take a second and think about that. What if the soil, this incredible living system that grows our food, was slowly suffocating? It sounds kind of dramatic, I know, but this is a very real problem that we're going to unpack right now. All right, so here's our roadmap. First, we'll get into why soil needs to breathe in the first place. Then, we'll look at the science of what happens when it can't. After that, we'll uncover the incredible architecture that allows air to flow. And finally, the fun part. We'll get to the practical steps you can actually take to help your soil out. Okay, let's start with the big why. I love this idea of thinking of healthy soil as having its own pair of lungs. Because, it's not just a pile of minerals, it's a living, breathing ecosystem. So, we have to get this idea out of our heads that soil is just inert dirt. It's not. Healthy soil has this complex architecture. It's a whole system of particles and pores, and the way they're all arranged is what dictates how water, and more importantly for us today, how air can move through it. This structure is everything. It's what determines whether life can thrive or, well, struggle. Now, the technical term for this whole process is soil aeration, but really all it is a simple, constant exchange. Life-giving oxygen flows in, and the carbon dioxide that gets produced by all that life underground flows out. It's an exhale and an inhale. Without this gas exchange, the entire system just starts to shut down. So, why is this such a big deal? Well, first off, plant roots are alive. And just like us, they have to respire. They take in oxygen to burn sugars for energy. It's simple. No oxygen, no root respiration, no growth. And second, that huge community of beneficial microbes in the soil, they also need oxygen to do their job. Breaking down organic matter and making nutrients available for those plants. So yeah, the bottom line is a healthy soil is an oxygen-rich soil, period. Which, of course, brings us to the dark side of the story. What happens when the soil chokes, when it gets compacted or waterlogged, and the oxygen just runs out? This is where things get really interesting and, frankly, a little bit scary for your garden. This slide just lays it out so clearly. You've got these two paths the soil can take. On the left, you have an aerobic or oxygen-rich environment. Healthy roots, nutrients are cycling efficiently. It's a thriving system. But on the right, when the soil becomes anaerobic, starved of oxygen, everything changes. Roots suffocate. And you see that second line? Nutrient cycling turns into nutrient loss. Let's dig into how that happens. That process has a name. It's called denitrification. Basically, when microbes run out of oxygen to breathe, they start scrambling for an alternative. And they find one in nitrate, which is a key form of nitrogen that plants desperately need. They essentially breathe the nitrate instead, which converts it into nitrogen gas, and poof, it just escapes into the air. Your soil's fertility is literally leaking away into the atmosphere. And believe it or not, it gets worse. A byproduct of this whole denitrification process is nitrous oxide, or N2O. And this isn't just a loss for your plants, it's a major problem for the planet. Nitrous oxide is a greenhouse gas that's about 300 times more potent than carbon dioxide. So a suffocating soil isn't just bad for your garden, it's actively contributing to climate change. Okay, so we've seen the problem. And yeah, it's a big one. But now let's look at the solution, which all starts with understanding how a healthy soil is built to breathe in the first place. It really all comes down to its physical architecture. So the most basic building blocks of soil is its texture, the mix of sand, silt, and clay. Sand particles are big, which creates these large pores for awesome drainage and aeration. Clay particles are teeny tiny, great for holding onto water and nutrients, but they can get compacted really easily. And silt? Silt is kind of that Goldilocks, happy medium. For a lot of plants, the absolute sweet spot is what we call loam. It's about 40% sand for that great aeration, 40% silt, and just about 20% clay to hold onto enough water and nutrients without becoming a swamp. It's really the best of all worlds. But here's the twist. While texture is important, it is not the whole story. The real secret to a well-aerated soil isn't just the particles themselves, but how they are all assembled into these stable little clumps or aggregates. And this assembly isn't random. It's the work of a whole team of living architects. So let's meet the crew. First, we have the primary architects. That's the plant roots. Then we have the weavers. Those are the fungal networks. And finally, the master engineers, earthworms. Each one plays this unique and absolutely essential role in building a soil that can breathe. You know, plant roots do so much more than just suck up water. As they grow, they're physically pushing soil particles apart, which creates these natural channels for air and water to flow through. Plus, they release these sticky substances, these natural glues, that start binding all those particles into stable little clumps. Next up are the weavers. Fungi send out these microscopic threads called hyphae, and they form this intricate web that runs all through the soil. These threads are coated in this super sticky protein called glomalin, which acts like a biological superglue. It wraps around those clumps the roots made and holds them all together, creating a stable, porous structure. It's amazing. And finally, the engineers. Earthworms? Man, they're just incredible. They tunnel through the soil, creating these massive superhighways for air and water. And as they move, they eat organic matter and excrete it as casts, which are these perfectly aggregated, nutrient-rich little powerhouses that are also incredibly porous. They're literally building a better soil from the inside out. So, this brings us to the final and I think the most important part. Now that we understand the problem and we've met the architects, what can we actually do? Let's get into the practical steps you can take to revive a suffocating soil and really help it breathe again. Okay, here's the game plan. It's a pretty straightforward 3-part strategy. First, you've got to feed your architects. That means adding organic matter like compost. It's food for all the microbes, fungi, and earthworms. Second, plant what some people call living tillers. These are deep-rooted plants like daikon radish or alfalfa that will drive channels deep into the soil for you. No digging required. And third, and this might be the most important one, protect the structure they build. This means reducing or even eliminating tilling, which just shreds those delicate networks that hold your beautiful soil together. Ultimately, it all just comes back to this idea, right? A healthy, breathing soil isn't just about chemistry or physics by themselves. It's about finding a harmony between the living biology of the soil and its physical structure. When we learn to work with these natural systems, the soil really does take care of itself. So, I'll leave you with this question. After seeing just how vital air is for all the life that's down there beneath our feet, what's the first simple step you'll take? Maybe it's adding some compost, planting a cover crop this fall, or just deciding to put that tiller away for good. Every small step helps build a healthier, more resilient soil. Thanks so much for joining us for this explainer.